Okay, hi everyone. This is the immersion cooling panel. High on hash, high on hash. Are we high? Are we hash? Are we immersion? That's the questions that we're going to tackle in this panel. Let's start with an intro round. Let's go through and everyone say what you're doing, where you came from, and when you first touched immersion.
None of those. Dave Beberman, CTO of Prasga. We're a new blockchain technology company with a hybrid proof-of-stake, proof-of-work.
I'm Gary Testa, President and CEO of Engineered Fluids, and we've been immersing devices for 7+ years now.
I'm Patrick Sweeney, CEO of DaVinci 3.0, and I started in immersion in 1999 when I was running a company called ServerVault.
Daniel Wong, President of Edge Data Solutions. I think first time we touched immersion was about 2017.
David Branscum, formerly VP of Business Development at Midas Immersion, and now I'm an independent consultant.
When did you first touch it? Yeah, when did you touch it?
Oh, when I first touched immersion? 2020. January 2020.
Drew Null, Vice President of Crypto Commercial Operations with TMGcore and Silex, and first touched immersion in 2018. Thanks.
Hello everyone, my name is Denny. I'm from Poolin. I work for as the Director of Business Development and also the site operation. For me, I didn't get in touch with immersion in the 1990s. I was born by then. But but I have learned about immersion, since the first day I joined the industry back in 2020, early 2020, and also, for us, we have been getting to immersion for the last year, and for the last couple of months, we have been expediting the process to become fully commercialized on immersion.
All right, and I forgot to introduce myself as well. So I'm Phil Salter. I'm CTO of Genesis Digital Assets. I touched immersion first in 2016, and then for a while not. Yeah.
So I think we can call Denny the immersion generation.
Okay, so I guess let's get started on immersion. Basically, I don't think that just a couple of years ago that there was so much talk on these conferences about immersion, and suddenly the whole market has exploded. That there's lots of companies like you guys around. There's lots of people actually deploying it. There's reports of companies really going all into it with over 100 megawatt of deployments and so on. So it's become a really central topic in the technology space regarding in the Bitcoin mining. What would be your what's your impression of what status immersion currently has in the industry? How much adoption do we have right now? What's the current status quo?
I can give a quick opinion on that. So you're definitely right. If you had been back here 3 years ago and you walked around and you looked for immersion cooling, there's probably maybe 1, 2 of us out there talking about it, and most everyone else was laughing at us. I tell you today that I think that we are capturing, as a group in an immersion cooling basis, particularly at industrial scale, at least half of the mining market in the US, particularly down in Texas. And now what we're starting to see is a massive adoption happening overseas, particularly in the Middle East.
Yeah, I think the reason we're seeing a big adoption of immersion now is we didn't think we were going to see 3 nanometer, I think, this quickly. We've got machines that are going much faster than they ever have. The more expensive the equipment, right, the more case you can make for immersion. I'm not going to typically put an S9 that's maybe a couple $100 into an immersion system, but if I've got a nice brand new equipment that could run really fast, we weren't able to overclock 50%, 60% before. We were overclocking 15%. We could still make a strong case for immersion at that point, but at 50, 60, immersion's really selling itself at this point.
Yeah, that's definitely true. I mean, you're seeing that return on investment, particularly from overclocking, which is really what's driving the big industrials, that and the ability to reduce maintenance.
I'd also be interested to hear, I think one of the driving factors is in southern US, we don't have this issue, right? But heat recapture. I think there's some really interesting projects that are underway right now, being able to reuse heat for things like grow houses, hot water, warming buildings, all of that kind of stuff. And the dielectric fluid gives you a lot more flexibility for those types of projects. So I'm seeing a lot more projects popping up for that, especially in the northern U.S., Canada, and then all over Europe. So,
like just off the top of your head, how much % of Bitcoin's hash rate would you just guesstimate comes from immersion? Just to add on top of the question.
I'm gonna throw out 30%.
I think it's less. I think it's maybe only about 15% right now, maybe 20%. I'd love to see it. I think it's going to be at 30, 40, 50, definitely the future of it. Yeah. And as there's more demands for properties, you're having to go to tougher places to reach, which is why you're seeing people that need immersion in order to open up access to properties that have, power, reliable power, in more challenging climate areas where you just can't run air efficiently.
Yeah, I think that's the big driver. I think we're starting to see that the cheap power used to be in places that were cold. Now we're finding cheap power in places that are very hot. And as that continues, it's the only way to go is immersion. Otherwise, your expense in terms of operational cost and your inability to actually get enough devices deployed in a small area, all of those are the drivers.
I feel like for immersion, the market share has, I don't know the exact number, but I would say around 20 or 15%. But you will see a much, bigger increase rate for the coming, in the last few months or last year. If you go into the conference, the mining conference last year, in May or in November, you will see only a small percentage of the vendors that come into the show with the immersion technology. But now you only now see more and more people joining the immersion cooling technology as a player, but you'll see more and more vendors coming up with some, more customized design on that. And, in terms of, as David said about the more possibility and optionality in terms of immersion cooling, we do have a little bit of experience before when we were still mining in China for reuse of heat. And, that was something that can be more sustainable approach for the whole industry. And then, something that the people in Europe and people in the rural part of the country where have the mining operation has been working on.
So I think it's important not to lose sight that when you're immersion cooling, you're overclocking. You can take a 110 S19, overclock it to 185, 190, and that's a lot more mining and hashing power. So those numbers are going to be a lot higher than an S9 sitting on there. It might be by numbers, maybe it's 10% of the miners out there, but by hash rate and total hash rate, I still think it's high 20s, close to 30.
That's a great point, sir. So in terms of overclocking, I do think that for the whole industry, even though people are getting better in terms of educating everybody in terms of immersion, but the majority still have a misunderstanding or a presumption that when everybody talk about immersion, they will first talk about overclocking. But the thing is that when you overclock, there's a risk for your power efficiency to become less efficient, which means that if you overclock too much, like you said, sir, so there will be a chance for you to run your S19J Pro as an S9 and potentially broke it with the same life expectancy as the S9. So you have to be careful on that. And then immersion, I do think we believe as a company, Poolin, we believe that the ultimate goal for immersion is to actually run stable, to have a stability and also durability in the long term.
Yeah, that's good. So basically, I think everyone here already knows, like the basic idea of immersion is, most people's business case is that you want to spend a bit more on the infrastructure and then get it all up and running in a more professional way so that you can run at higher hash rates. So it's kind of, it's a kind of a balancing act. So let's ask it the other way around to make it more interesting. Like, what kind of people should not do immersion? And in what kind of scenario does it not make so much sense? Or is it always a win-win?
Well, so kind of the antithesis of overclocking, right? Obviously just running a stable right at what the miner is designed for. I think there is actually a business case for immersion in that direction as well. Brains released a pretty good article not too long ago talking about efficiency, hash rate per joules, things like that. And what they found was when you're running a miner as it's intended, as it's designed, removing the fans, let's say an S19 is running about 3,000 watts. If you're cooling those chips, if it's designed the right way, every model's different, every chipset's different, but if you're running those the right way, they showed that you got a better efficiency out of your miner. For example, you still got your 110 hash rate, but instead of 3,000 watts like you would calculate and engineer for, you're actually running it at 2750, 2800. It depends on how cool those chips are. And so as immersion solutions get better and better and better, right, we can keep that efficiency. So maybe your ROI is different, maybe your payoff's different, but if you're paying a high price for power, you're not just saying how much hash rate can I get, how much can I buy, I want to own, you know, so much percentage of the hash rate, whatever, then you can, it's still, I think, it's still a business case if we can keep the price, bring the price of immersion further and further down, just make it more accessible as we get smarter with the solutions, things like that, and be able to make a really strong business case, even just running it at your standard clock rate. So.
Yeah, we do immersion. We don't do AV, right? I think to answer your question, I don't think there is anybody that shouldn't do immersion. I think that there's a business case and there's a use case, regardless of what your context is. I think there's an application there that's meaningful for immersion. And I think the thing that's really interesting that we're seeing, and an exciting thing that we're seeing, is that, you know, when immersion first started coming out, you were seeing it more in larger scales, you know, and now what we're seeing in the market, especially, I mean, this conference being, you know, if we look back at BTC 22 back in April to even to now, you're seeing a lot more applications of folks that are, there's a spot for everybody in the market. So you're seeing there's applications of the tech at large scale, and there's even applications that we're seeing even here today for somebody that might just want to run 4 or 5 or 6 miners in immersion. And there's a place for all of that. So I think that regardless of your scale, I think that there's a place for immersion, and I think that that's the really exciting thing, that we're seeing that total ecosystem develop for those that are, you know, maybe more of a hobbyist miner to those that are doing large scale deployments.
Yeah, I have to agree. We sell a whole lot of very small systems to home miners, and the primary driver there is noise. Their wives don't want the noise. And it's always the wives that don't want the noise. For some reason, we seem to be able to sleep through anything.
That's because us men are deaf anyway.
Yeah, exactly. But the other thing that I think that we don't talk a lot about, we talk about overclocking. We don't talk about the fact that the miners are actually online longer in hashing and immersion. When you walk into any air-cooled, you know, mine, you walk around and you see all those red blinking lights out there. All those miners are offline. They're either reset. But when you go into an immersion mine that's been properly set up with good thermal, good flow, everything is green. And we did a very interesting study, and we found out that it's about a 20% improvement in the number of devices that are hashing at any one time. And that is almost as good as overclocking. If you can keep all your miners online with very little maintenance, that is a return that you have to add into your business case.
Yeah, I mean, I'd say you've got to calculate how often your miner's failing, what's the maintenance cost, how often you're having to reset them, how and do all those things. And I think if you do the immersion the right way, not only that, a constant chip temperature also means you're now having a steady hash rate. So a lot of times in air-cooled facilities, you're going to see a higher hash rate at night when it's cooler and a lower hash rate when it's lower. That's also hard on your machines if the temperature is fluctuating all the time. And you'll also start to see that if you're at a higher hash rate and a steady hash rate, those pools will send you a larger packet of work. It's actually more profitable to run immersion because of that specific reason.
The other thing that we shouldn't lose sight of is immersion's much better for the environment for a couple of reasons. But first and foremost, if a system is designed from the start to be immersion only, you've got a tremendous amount of foregone electronic waste. So you don't need fans, you don't need cases. You can just put hashing boards in immersion, and then when it comes to upgrade, you don't upgrade the whole system, you just upgrade the boards. So it's way better for the environment as well.
Yeah, so in terms of operational wise, since I also is responsible for our mining site operations, so I have a very direct feedback on that. So usually for air cooling, you're looking at one maintenance IT tech to manage around 500 units of machines. If you have better training, you have better management, it can go up to 600 or 700 machines. But that's the optimal number for one tech for air cooling. But if you look at immersion, you are looking at a longer period of time for stable operation, which it's going to be a little bit hard in upfront for the setup, for the system setup. But once it's setting up, you're looking at one person can manage up to 2,000 machines. And then, before, for those who are managing an operation outside of U.S. to the other side of the world, you guys will know that the labor is relatively cheaper than the U.S. But now, since U.S. has become the the hash rate center of the world, and then you guys already know that the labor cost in the U.S. has been crazy, and then think about that as a huge deduction in terms of operational cost.
That's a good point, Denny. Actually, I was going to ask as the next question, the technical implications of immersion can seem a bit daunting to people coming into it. Because, I have a lot of experience with air-cooled miners, right? It's comparatively much more simple. You have your shelf, your power, put your miners inside, and then you manage them. And it's kind of okay. If you make a mistake, it's maybe one miner breaks, yeah. Yeah, that's kind of okay. But with immersion, you're dealing with hydraulics, you're dealing with pumps, you're dealing with this fluid, you're deling with watertight enclosures and all this kind of stuff. And it all has to work together. And there's always big batches of miners that if something goes wrong, they're getting hot. So, people that are worried about getting into it because of this huge, learning curve of getting into immersion, what would you recommend? What kind of learning materials or what way forward?
That's a very good question. So I think of it two ways. So on the first part, from the designer, from who designed the system, mining is always a equation of subtraction. It's never an equation of addition. It has to make a complicated thing to be as easy as possible in order to do it, in order to operate. If you have a whole complicated system, even for immersion or for other hydro or other stuff, it's going to cause a lot of trouble in terms of collaborating internally the team. So for us, what we're trying to do is that first we design a system as easy as possible so everybody can understand simply by looking at the physical structure of the system. And the second thing is that, due to the high labor costs and construction costs, development costs in the U.S., so we're trying to minimize that by, having a more prefab system. So, it can be easy as Lego or IKEA, so you can just have them ship in and then just plug it in. And then it will be easier for them to understand by just looking at the IKEA map, the instruction page.
I think that's a key part. I would say don't do it because this shit is really hard. Buy a system that's made by someone who knows what they're doing. And I'll tell you a quick story. We've been in stealth mode for 18 months. We launched a company a month ago with super smart guys. So most of our teams from MIT were up in Boston, and we were trying to optimize our system. So we thought, okay, we'll start with PVC. It's lighter, it's easier to use. And we were running immersion fluid through PVC, and we had a flash electronic event because of all the static electricity that had built up that nearly sent a guy flying across our lab. So if you're messing with that at home, and these are like MIT guys, Cornell guys, big foreheads, really smart guys, right? And we're doing that kind of stuff, and we made so many mistakes in our first 2-3 iterations of the design of this that I would say don't try it at home. Buy there's so many great systems out there now for 1 or 2 miners, for 100 miners that, buy something that's designed by professionals.
And I'd say immersion's really simple. I mean, at the end of the day, it's simple. We take fans off, you put the firmware on it, you spoof the fans, you put it in. You never touch it again, really. I mean, you can fully pull miners out and you can work on them and do whatever you need to do, but it's really designed to really protect that miner. You're taking out most of the things that cause a miner to fail. Heat, dust, moisture, chip swelling, all those types of things. You're pulling that out of there. So the chances of you having to do a lot of maintenance on it are pretty minor. And most systems, we're talking about greasing pumps, maybe washing some coils on heat exchangers. It's less maintenance that you're doing in air. If you could do air, you could do immersion. It's just a different way of doing it.
I would tell you that if you're serious about looking at it for the first time, go on the Engineered Fluids website, download the Slick Primer. We published an 80-page presentation almost 4 years ago that gives you the step-by-step how to do it. And you're right, there's a bunch of things you can really make a big mistake on. Grounding, probably one of the most important things you can do. It's not impossible, but what you have to do is pay attention to flow rate. Right? That's the most important thing in these systems. After you figure out the piping and the plumbing, All of that's doable. But if you get your flow rate wrong, if you buy a tank that isn't properly designed, you're going to end up with a whole host of problems, and that's what drives people away from immersion. I think the biggest problem that I see in the industry right now with the immersion adoption is one of the things that Denny said, modularization. Make it small, make it plug and play. Make it so that it works. Buy a system that's already engineered if you're not willing to engineer it yourself. This isn't hard, but if we as an industry, and I'm talking about us up here, if we don't deliver systems that are functional and do the right job, the folks in the audience won't be able to adopt it at scale. And I think what we're seeing now with 100 megawatt plus systems being installed is we're figuring this out. But again, if you're just starting out, you're just interested, go look up the Slick Primer. It answers a lot of those questions.
Yeah, and I would just add onto that, Gary, I think going out and having conversations with the providers is key. You know, there is a lot to learn about immersion, but it is simple. But you need to make sure, what I would say is make sure that you pick a partner that's going to partner with you. You know, make sure that they're going to be there to support you, that they're going to be there to educate you. You know, any partner that's just going to ship you stuff in a crate and say, hey, have fun, don't buy their stuff. You know, that's not a good partner. You want somebody that's going to educate you so that you know how to run what you're doing.
Yeah. No, you know, I think I'm also convinced, you know, we got the 80-page paper, then it's the piping, the plumbing, and then the flow rate, and then you just got to do the grounding, right? I'm just kidding.
That's all you have to do. That's all there is to this, right? Just throw it. I had a customer call us up and said, I put my miner in your fluid. It's in a 5-gallon pail, and it keeps overheating. And I said, well, where's your pump? Pump? What pump? Where's your cooler?
No,
it's interesting. People.
I'm kidding.
No, but Phil, you're right though. People, that's the assumption that they make.
But
Phil.
what I was thinking is, you know, just 2 panels ago, it was the panel on ASIC miner repairs. So basically, people specializing in working on other people's, not the manufacturers' machines, helping people to repair them, even though they're not the official support. So I'm thinking, are we maybe going in the same direction for immersion cooling? That there's going to be like, you know, consultants or like techs or some integrators or something like this.
Pop up. Yeah, absolutely.
Yeah.
So that's basically where I'm at, right? I'm the only one that says independent consultant. I'm independent. I'm on my own, but I can hold my own, so it's okay. So I think what's been really interesting for me from this perspective is, right, I mean, you know, when you say, is there a case for, you know, who shouldn't, right? Well, we're all a little biased, right? Everybody should use immersion, right? That sort of thing, but that's a good thing, right? That's going to drive the adoption. That's going to drive the education. I'll drive that, the safety conversations that are so important, right? But what's interesting for me from this position is I'm getting to take a very good, you know, impartial look, right, at all the systems. And what I think when we're talking about, you know, if you want to get into it, safety issues, stuff like that, there's an immersion setup on the market now for whatever your level is. Do you have to do the research? Yes. Should you learn as much as you can? Yes. If you don't feel comfortable, you know, going out and wiring a panel in your garage, well, you probably shouldn't get into immersion yet either. You know, it's like whatever you get into, do your research. Like you said, find the right partner, right? And everybody up here on this stage offers different levels of service, different levels of different product levels, different size projects, all of that kind of stuff, right? It's from, like you said, it's from 2 to 4. Just take your time, do the research, make sure you feel comfortable with who you're working with, and that's your answer, right? Get the support you need, but it doesn't matter what your level is. Just take your time, do the research, understand what you're getting yourself into, and you'll be fine. And the benefits are there. Everybody at least should consider it.
I mean, one of the things we do is we really want to understand more about the client. I'm not going to sell you a solution unless I know it's the right solution for you. So I really like to go through what are your goals, what are you doing, how are you doing it, and I'll flat out tell you, hey, maybe our system's not a good fit for you because it's not going to meet those goals. I would say for us, if someone asks me, Dan, should I put a bunch of S9s in immersion? I'm going to tell them no because the numbers don't make sense. Yes, I love immersion. I want everything in immersion, but you have to also look at all the other features of the business to make sure it's the right case for them. So one of the things we do is we'll send people out to do the installation. We'll even train the people on the installation so their own team, their own support can help with it. That way we make sure they're supported through the entirety of the project and you're on site, anything they need.
I think one good way to actually do the consulting is that to actually visualize your design. So the design of the system doesn't have to be fancy, but it has to be, like we said, easy and straightforward. The customer, the client can be, easy to see how the system works based on the physical being over there. And then the other thing is that, we have developed a software called Poolin Management Platform, PMP, which is, all-inclusive, one-stop mining management software where you can do all the configurations and you can do all the monitoring work. So that will make, the monitoring for the pump, the tubes, the pumping, and also the pressure, the temperature to be a little bit more easier with the visualization. So you will see from the diagrams on our system and also from the physical system to see if there's something wrong, you can do, take actions on that. And I think many of the people on the stage with what they're doing are also doing the same thing.
Very good, very good. Yeah, I like it. I like it that we're on a panel here where everyone's got, just like you were saying, a slightly different spin on the industry, offering slightly different services. I think that's really good because it's showing that we're not like in a fully mature, long-term market yet where everyone's doing the same thing and it's just about, a fraction of a cent different costs. It really we've got people looking at this from different angles, trying to tackle the problem in slightly different ways. My next question would be, where do you see the industry evolving into? I mean, we got the fluid, we got the tanks, we got the miners. Like, what's the next step forward? Where's innovation happening in this space?
Well, I'm gonna turn this over to Patrick in a minute because I think he's got the answer that I'd like to hear. The thing is, I disagree with only one part of that, Phil. We don't have the miners yet, so I'm gonna turn this over.
So we do have the miners. So I think the future is a system approach. So what we've been designing for 18 months is the first industrial scale system that's immersion first. It's plug and play. It goes outside. All you do is hook up a three-phase power to it, and you're mining immediately. And that kind of thing with near zero maintenance. So all the system design that's gone into it was thinking, what is this like at a large scale? It's the same thing that EMC did with storage in the 1980s and 1990s. Used to be you put up a server with a GPU or with a CPU, with a storage, with RAM, and then they said, okay, well, what if we just had blades of storage, one central system running it? It's the same thing. We need industrial scale design, and there's no doubt about it. The future of it is immersion. So you can't do industrial scale design with all the extraneous chasing diminishing returns by using air, because the chips, as Dan said, chips are getting smaller, they're getting more denser, they're getting more per board, and that means a higher heat exchange and more to dissipate. That's got to be done with immersion.
Well, and that's the key, right? When it's smaller, I need to get more efficient with it because it's not going to keep leapfrogging itself in terms of performance. That's why you're seeing so much towards that. We've seen the S19 Hydro. You've seen other miners that are coming out and they're really starting to adopt that. But what I see it going to is you've got a much more data center industrial type of investors and people coming in now. People with those data center backgrounds want the granularity, the controls that they're used to seeing in data centers, whereas before, the wild, wild west of stick it in a warehouse and just run the heck out of them in a dirty warehouse isn't going to cut it now. So if you want to go to big investment houses and you want to get big projects, you got to show them that you're going to run it properly and you're setting it up professionally at pretty much an enterprise level at this point.
So kind of on that note, right? It's been really interesting to see how quickly this market is moving. But it's really interesting too because, like he said, right, we're at a point now, especially with Bitcoin, the price where it is, and all of these kind of more traditional investment opportunities and money coming in. We're at a point now where it's yes, we're still creating new systems. Yes, we're still finding unique, innovative ways to use it and things like that. But we're also, it's incremental. A lot of it's incremental. What are the incentives to use immersion, right? So there's actually some tax credits that are available if you are setting up a operation in a particular location, right? Well, those tax credits may actually pay for your immersion system, essentially, right? So what we're looking at now is we're seeing immersion is not just, hey, should we not use immersion? The question is, how do we use it? How do we make this a part of our infrastructure? Looking at it from that application, right? And what's really interesting is, so Bitcoin is considered an emerging technology. Blockchain is considered an emerging technology, right? Well, any sort of research and development in regards to technology in the United States, right? There's some pretty good funding and tax credits available. Well, so that means every miner out there hashing, right, is research and development. Until we figure this out, until it's mass adoption, until the laws change, you can actually, so we're starting to see real business come in, and I mean big names come in and say, no, we're going immersion. The question is just, how are we going to best utilize this for our business plan? Which that is what I think is really exciting, because that's going to give those big investors an incentive to move in quickly and in a big way.
Yeah, one of the other things I would add, in addition to everything that everybody said, I think one of the other things that we're going to see coming, in terms of innovation and immersion, is different technologies in how we do the final heat rejection. Right now it's dry coolers, it's evaporative coolers, adiabatic, whatever. There's a lot of things that are just now starting to kind of scratch the surface on how we do that, and it's guys and gals that are way smarter than I am that are developing it. But I think that's the next wave of innovation that we're going to see in immersion, because that's a critical part of our infrastructure. You've got to do that final heat rejection, whether it's on the oil and you're using a single loop or a dual loop and you're cooling water, whatever the case may be, how you're doing that final heat rejection more efficiently, more energy efficiently, more effectively, lower cost points. That's what I think is really going to be the next shift that we see in the immersion space, to be more flexible in the way that we can deploy things. Because right now it's a fairly fixed manner in how we do heat rejection, final heat rejection. But I think what we're seeing in the market, and there's some things that are coming in terms of technological innovation that are going to make that a more interesting and a more flexible thing and a piece of our deployments.
So I'm going to go in a slightly different direction, because I'm not an immersion technology company, which is why I'm here. Is an interesting question to start with. We need all of your hash power. Okay, so what you're doing is you're creating a more green approach to hash power by what you were just describing, right? What we're doing is we're taking the hash power and creating more output from it. So right now in Bitcoin, you do a fixed amount of output. You're all fighting over the same blocks, where our technology is about increasing the throughput with the amount of hash power. So that essentially makes that green in its own space, because of course, if you increase your capacity and you can increase the output at the same time, then it's a wash. So what we're looking for in your space is as much green you can do out of it, particularly in the heat dissipation. Okay. And the only other thing I was doing, which is totally unrelated, is if you overclock your chips heavily and you push the heat up on them, you're also seriously reducing their mean time between failure. Right, so I think I'm very much on the side of the guys saying, be a little careful about how much, because you get an exponential, heat's exponential, not linear. So you may be beating the hell out of your machines unnecessarily. And then you go back to the question of what's green. If I'm overclocking my box and I'm eating a whole bunch of power to do it, to get the same amount as I could with two boxes at a lower power, at a lower clock speed, you might be a little more green. And it's very common in the industrial industry, of course, to run lots of smaller boxes at lower processing speeds, lower clock speeds, specifically because of that. So you might be a little careful pulling that off. Now, most of you guys are the manufacturers of it, but just as a knowledge piece, because we're looking for as much green as we can.
We've all touched on heat reuse, and I think of all the things that I see happening, it's a shame that in the United States we're not spending as much time focused on that as they do in Europe. They have obviously an advantage with centralized heating systems. We have a bunch of really interesting customers out there that are heating greenhouses, heating pools at large facilities, heating their homes. There's an infinite number of applications to really bring immersion cooling, because once it's in liquid form, you can move it. We have customers moving our hot fluid kilometers in order to move that heat around. You can't do that with air. You can't repurpose it. So we need to get more innovative on our side. Can we put a greenhouse right next to one of these mines, right? Can we have tilapia grows? We have fish farms. That when you really start to think about it, there's a large number of applications that can utilize the heat. I've even got a customer who's using the heated fluid coming off their miners to drive an air conditioning system to cool the rest of the facility. So when you start to do things like that, we can take this into a whole new green realm, and I think in a lot of ways eliminate a lot of the stigma. You know, we know that these companies can't turn down their power, right? You don't. If you're a utility, you simply don't turn it off. We're utilizing that power to do something. Now we've got to utilize the heat generated by that power to do something.
Yeah, I really agree. I think finding better avenues to use the waste heat from mining would be absolutely game changing. I mean, also for air cooling, but I guess also for liquid it's much easier. Yeah, we actually have a greenhouse up in Sweden that we heat with air cooling though. But yeah, with immersion that works much better. Yeah, I think the step that we need to go to get that really more widespread is to have more smaller contained units of immersion to be like easy to manage. Like if we're a guy managing, let's say 100 small deployments, like one tank for each like a swimming pool or something, I think probably that's still a bit of an overhead right now, but we'll definitely get better with it.
But what about replacing, right now Europe's got a major energy problem going on with the cutoff of gas from Russia. What if we could build a lot of little mining devices that could be used to heat homes to replace that? You know, there's a large number of, as you said, Phil, small applications. You know, we tend to think in terms of hundreds of kilowatts, but I've got 6 miners heating my pool at home. Works great. You know, there's no reason that we can't find other applications like that.
Okay, perfect. Well, on that note, we're talking about innovations in the immersion space. What would you wish for? What would you wish for miner manufacturers to change about their machines to work better with immersion? I see faces lighting up.
Who's going to take that?
I'll take it first because we did it. It's a caveman approach, right? The fans, the single units were designed to be used one at a time, never in parallel, never in serial. So what manufacturers should do, and it would be a great success and really well received, sell the boards. Just sell your PCBs, sell your ASIC, sell the boards, and let us design a system for them to go into.
Yes, I was about to say that, sir. Yeah, so hopefully, all the manufacturers have been, I think they have already been doing that. So they have realized that the increasing number or increasing acceptance for miners towards immersion. So what might happen in the future is that, we'll see more customized miners from the manufacturer in terms of specifically for immersion. And then you will probably see some of the manufacturers will sell only the hashboard, which is customized for immersion directly, and yeah.
I mean, that's the first thing everyone says is, if you're putting an immersion, what do we need this housing around it for? It's the first thing everyone says. And I go, yeah, we don't really need it, but there's no miners out there that are really just hashboards at this point that are putting it into some sort of a carriage that can drop it in. So if those manufacturers could help design this, there's a couple, but it's not as widely adopted. I've seen it done in China a while back, but not as much adopted here in the U.S.
It's the labor. You got to take them apart. You've got to clean them. I mean, getting into that. If they would just sell us the hashboards, the other thing they could stop selling us are all these heat sinks. Let us do the heat sink. You can quit putting thermal grease and gunk and crap all over the miner. I could give you a list of about 50 things we could change. How about putting all the connectors at the top instead of on the side or on the bottom or anything like that? The other one would be, how about the ability to daisy chain control cards to each other, since there's not a lot of network bandwidth going through there? I mean, all of these things would make developing and building an efficient immersion miner system as a whole a lot easier. And I've provided all of that feedback to a large number of mining device manufacturers, but it's frustrating because they always go back to air.
Yeah, they do. I can say this just on an encouraging note. I personally have had conversations with 3, the major manufacturers, right? And they're all taking notice now, right? So it seems like even just 6-9 months ago, you'd approach them and have that conversation like, oh yeah, that's cute. I like your design ideas, thank you. And that was it, right? And it's like, and so it was up to the creators of the solutions to figure out, okay, how are we going to make this work? And then the operators were like, are we going to void our warranty? I mean, there's all of that, going on. But all the conversations I've had have been very, very encouraging. They're starting to open up and work with these designers, right? I think that's what's so exciting about the future is these are two very unique technologies coming together. I heard a quote the other day. It was, invention is creating something new. Innovation is bringing things together in a new way, right? So there's been a lot of creation, right, of some incredibly cool technologies. How are we going to bring those together, use them for, and design for each other, right? It's going to happen. It's going to happen. And that kind of innovation, I think, is what I'm so excited about. So,
one more thing to that point is one of the limiting factors for the technology to continue to rapidly change and get hotter and get faster is the ability to cool it. So I'd like to see them really push the envelope. Can you get it hotter? Can you get it faster where you can't run that in air and you can only run it in immersion? Is going to open up a whole new wave of technology that's going to be faster. You got to remember, there's all this new technology going on in the data center space, and we're going, this infrastructure hasn't changed in years. So why is the infrastructure lagging so much farther behind the technology? But now we've given that ability to really push the envelope on the technology with immersion. So I'm really looking forward to what they do.
There's one other thing that they could do that would make all of our jobs a lot easier, but would actually have a major benefit to our ability to actually use this, which is let's design devices that actually function really well at 100 degrees Celsius and above. Because one of the things that you can't do when your tank is, pushing out a maximum of 60 degrees is do anything like low energy Rankine cycle. If we could get the fluid exiting the tanks out at like 120 degrees Celsius, there's a huge number of industrial applications where we could use that heat and actually generate both power, cooling, and everything else. And it can be done. Again, it all comes back to that design. But because we're designing for air, we're all targeting that 75-degree chip temperature.
Very good points. Very good points. So, if we're now talking about modifying the miners, modifying the hash boards to be more specific for immersion, and we've got our custom PSUs at this point, and we've got our custom software, and we're really working on this properly. So, what about that next step of thinking? Saying, all right, how about two-phase immersion cooling? For those that don't know what it means, it's like you put the miners into the fluid, and it actually starts boiling, and then you have to condense the fluid. It's much more complicated. These guys definitely know. So. What do you guys think about two-phase immersion cooling?
So TMG, we cut our teeth doing two-phase immersion mining back in 2017. We actually worked with an OEM to manufacture vertical hash boards, and we did it. They're right now, to everybody's point, right now with the hardware that's on the market, doesn't make sense. You can do everything that you need to do with the hardware that's on the market in single-phase fluids. If the hardware continues to develop, there is a use case out there. If you can get it dense enough, you can get the chips hot enough. But right now, but there's a lot of when you look at the management of two-phase fluids versus the management of single-phase fluids, it is a much, we've been saying, immersion's simple. It's really not that big a deal. It's fluid. It's flow. It's fluid. It's a pump. That is not the case with two-phase. There are benefits for it. But in the mining space right now, it is a much more complex application. But there is a potential for it at some point in the future that if there was a material benefit in terms of how much hash power that those boards were able to generate, that there is a potential application for it. But there's a lot more in terms of the ecosystem that's going to have to develop around it to make that a more sustainable, large scale operation for sure.
We evaluated it first. We just couldn't wrap our heads around how that was going to be the technology to go with. I think that's why everyone here is running single phase. One of the big benefits they said for dual phase was the ability to get really dense and more power inside a tank. When you've got an extremely toxic fluid that's very expensive, hermetically sealed, and we're talking about safety of employees and things you're running, how you're going to operate on the machine. But now we're already getting to those densities with single phase. So that was the big pull towards dual, was I can get really dense. Well, we're getting real dense right now with single phase between everything we're running today.
We're still not hitting the limits on that.
Yeah, and just to make a point, if you're if you're running the fluids the right way and you're running the right fluids, it's not toxic. It is, there's plenty. Now there are some out there that if you run it the wrong way, it can be an issue. But if you run,
so which of the two-phase coolants that isn't a PFOA and doesn't? I mean, there aren't any. I mean, they just shut down the big plant in Belgium because of the saturation levels of that.
Right? I'm not going toe-to-toe with you on that, brother. I know you.
Because I know this.
One of us is a chemist, one of us is not.
Let me tell you something. There is not a.
If
you think PFOAs aren't a problem, let me help everybody.
Yeah.
Everybody right now in this audience, you have PFOAs in your blood. PFOAs are the base products that manufacture two-phase coolants. They are called forever chemicals because once they're released in the atmosphere, they never go away. I used to laugh every time I'd be on stage with the 3M guys in Novec, and they'd take the card out, and it was magically dry. And everybody thought that was really cool. My first question was, you just inhaled all the stuff that was on that card. Yeah, I don't think that there's anything wrong with two-phase cooling. It has an application. But all of the current chemical products that are used to do that are incredibly harmful to you, the environment, and everything around us. And I think until we find something, I really don't think that we're going to do that. That and anyone who's ever tried to seal a two-phase coolant system knows that you spend most of your time inhaling it.
If you really want to save everybody, go just tell them it's crazy expensive.
Well,
if you're wanting to look at it, right?
It's 10 times more expensive than the products that we sell, and we still get people on a regular basis calling us. Although I will say, though, that now that the European Union has eliminated the use of a lot of PFOA chemicals, we have customers coming to us asking us for alternatives. And these aren't in the mining industry. These are in solvent uses and battery cooling and a lot of other applications. And what that's going to do for all of us on this stage is it's driving immersion cooling into a wide number of other industrial applications that are allowing us to take advantage of that scale.
Yeah. I mean, yes, I agree with you. However, I think that there are more innovations coming on the fluid side, and to your point, there is an application for it. And if you learn how to manage it, there is an economical application for it. Is it widespread right now?
Well,
no.
But as long as we could find we evaluated manufacturing. Dr. Dave, who's our chief scientist and my partner, we could have made these materials, but at the end of the day, it's very difficult to find a substance that will behave properly. Whereas with single-phase coolants, the big advantage is no evaporation, no smell. The reason that's important, it means that the fluid stays in the tank where it should be, right? And yeah, you can wash your hands. So, I'm sure that there are very high-tech applications. By the way, space is not, and I get this question all the time, well, space, obviously that's a big one. No, two-phase cooling relies on this thing called gravity, and in space, when you have no gravity, the bubbles don't recoalesce and go back down inside. So,
yeah, okay. So everyone agrees on the two-phase cooling, so that hasn't changed over the years. It's always good to get an update every now and then. Now, I've got another reason, actually, why I hope that it doesn't go in that direction in the future, and that's just because, knowing how mining farms usually look like, what they sound like, what they feel like, and how low the entry point is to getting into it, I really kind of fear a future where you go into a mining farm and it's all kind of silver, stainless steel, beautiful robots or whatever. Was basically at that point, where's the fun, first of all? And also the entry barrier is super high. So in order to keep it decentralized, if it turns into that you have to do all these crazy technologies in order to be competitive in the market, and there's like 3 players that can do it, that would be harmful to Bitcoin. So let's hope that it stays like this for now.
Yeah, I'd agree. I think the ultimate Bitcoin, and I've been waiting for someone to actually execute, we've had some interest, is to turn a swimming pool into a mining farm. And it's totally doable. We've already done the engineering. We know how to do it. It would look a little wasteful from a fluid perspective. I'm okay with that. But on the other hand, it would be something right out of a movie, and it'd look really cool.
Well, I mean, that's the coolest thing.
Well, actually, if your kid jumped in, and just tell him to hold his breath, because other than that, he might have to take a shower.
I wouldn't mind a 60-degree swimming pool.
Yeah, you could. I don't know about you guys, and I probably shouldn't say this, but we sous vide lunch in our tanks all the time.
I mean, that's the
60
cool thing when
degrees is perfect for tri-tip.
when you walk into an immersion data center, right, or immersion cooled crypto operation, everyone's blown away that's been in an air one because it's a jet engine going boom, boom, boom. You walk into an immersion cooling, it sounds like a tranquil spa with light water droplets going everywhere. That's it. That's the only thing you hear. The only noise is literally coming from the dry coolers outside.
A really
cooling towers.
profitable tranquil spa.
Exactly, exactly.
Okay, guys. I'll get to the audience questions in just a minute. I got one more question, and that's that. I think that's a bit more relevant than here space tech two-phase. But hydro cooling, water cooling. There seems to be a competition going on at the moment between immersion cooling, put it in oil, and water cooling, and put pipes everywhere and have the heat exchanges on the chips. So they both offer kind of the same idea, right? Have a bit higher capital costs, but then have higher overclocking capability and hopefully higher lifetime and less noise and so on. So what's your take on this? Like, is there a back and forth here? Is it a parallel development? Where we're at?
Yes, so for Poolin, we have air cooling, hydro cooling, and immersion cooling all together. And for hydro cooling, I would say it's same, pretty similar logic with immersion cooling and the factors you have to control in terms of the pressure, pumping, plumbing, and temperature. Inlet and outlet temperature is the same. Systematic approach. And then for you guys, if you guys want to talk more about hydro and immersion, I'm feel free to talk about it. And then for me, I do think that if you can manage one, you can manage both.
So when we started evaluating 18 months ago what a system would look like, we looked at air, we looked at hydro, we looked at immersion. And one of the big things that came true was the maintenance cost and maintenance issues around dust and vibration. A lot of people lose track of both those things. Vibration, the very micro amounts of vibration are what cause the ASIC to fail. Those are exacerbated by heat sinks, and they're exacerbated by metal on metal or metal glued to a heat sink. So what we found when we tested is hydro is very effective short term. It's from an overclocking perspective equal to immersion, at least that's what we found. But from a long-term perspective and a maintenance perspective, you still have the same issues with having to clean things, having to keep the air, basically keep a clean room environment, and you still have the vibration issues. So those were the big things that led us to immersion.
I think safety. You're not going to catch me in a steel container with 1.5 meg of electricity and a bunch of water running around while I'm standing there in my shoes. I think, and we've seen this with direct-to-chip cooling and water, you have to spend as much investment on the leak management, leak detection, how you're going to, you have reverse pressure. There's a very complex number of things you have to do to really look at safety. On the other hand, with all the immersion systems that are out here on stage, we could spray the fluids all over you and everything else in your mind, and the only thing we have to do is take a shower afterwards.
I think just kind of from an impartial perspective, right? Not making a judgment call one way or the other, because like you said, it's gonna take some time, right, to see kind of how how that's going to affect, right? It's a long-term process, and these technologies are new to this application, right? But I think regardless of which one ends up being more efficient, which one is less cost, which one helps eliminates more of a barrier, gets more people into mining, like you were saying, Phil. I think that I just encourage the competition, right? I mean, I think everyone in here has created a system because they were driven to fix a problem, right? Well, competition's a problem, right? It's if someone's going to come along and do something better with you, we don't like that. We want to say, okay, great. What did they do? How does it work? What can I do better? Right? And so that's what I think the guys up here are driven by, different things, right? But the strive is to always be able to do something new, accomplish higher heights, do something better, specifically for this market, this environment, this technology. And so whatever the technology comes to market, I encourage it. We don't trust. We verify. That's right. So as we evaluate new technologies and verify how they really work, how they really apply, I just encourage that competition.
All right, perfect. Yeah, I think we discussed a bunch of innovations in the space, and I'm really, really happy to have the chance today to talk to all you guys. that's basically it. We got the time for an audience question or two?
We do.
Wonderful. Let's go.
Any questions from the audience? Immersion cooling? Cool. Here, let's let you go first.
All right. So, what projects you guys talk about waste heat? So I'm just curious, like, what projects are you guys actively doing that you're allowed to disclose and all that, that you might be using that waste heat for?
All right, so we have a customer called Green Tech that builds, also called sustainable data farming, that actually is using miners today and using the power generated from gas turbines. And what they do is pretty interesting. They take the CO2 from the gas turbines and pump that into glass houses in the Netherlands to grow vegetables. Then they use the energy being generated by that same gas turbine to run miners. That miners then generates Bitcoin, which pays for the electricity, and then they cool the fluid. It's all done in immersion in our fluid. Basically then is then pumped into a series of coils that heats water, that heats the roots of the plants, that actually promotes their growth. And we do that. I have another project in Sweden where they're actually using it to heat in the winter, to heat the sidewalks so that it prevents them from having to have the labor to actually move the snow. I have a tilapia farm that uses it to heat the fish pond that then creates the fish in the water that then feeds the lettuce. These are great full round. So there are a lot of projects. Are they at the scale that we'd like to see? No, I'd love to see some really large ones.
Hi. My question was having the appropriate capacity over the next 3 to 5 years as more and more rigs are going to be immersed. It sounds like the number's between 15 and 20% right now. How do you feel about the capacity to have enough dielectric coolant to do that? Yeah.
I'm sorry, I'm not sure. Can you ask the question so that I don't think we could hear you. I don't think the mic's on or you didn't have it close enough.
Can you guys hear me now? Sorry. So the question that comes up for me, you guys talked about 15% penetration so far. It sounds like in the next 3 to 5 years, how do you feel about having the capacity to fulfill demand from the mining fleets? And also the inputs that go into the dielectric coolant, how does the pricing for that, are you able to contract out ahead of time for the pricing for those inputs, or just want to learn more about the economics of that?
So it's about the question is about how fast can we scale it up? Like how much
talking
production
about
capacity?
basically if the demand is there, meeting the demand. Is that what he's asking? Yeah. Okay. So all you have to do is go back and look on YouTube at the panels the last 2 or 3 years. Right. The first panel was like 3 or 4 people. Something it was probably just Gary. Right.
I think I moderated that one.
Yeah. But I think that all you have to do is look at that, and last year I think there was maybe 2 or 3 immersion companies actually exhibiting. There's like 6 or 7 at least that I can think of right now. So I think the solutions are going to continue to be developed, continue to be driven. More and more people, create new designs. More and more people enter the marketplace. That's going to drive that competition. As far as the dielectric fluid, I think, and we talked about two-phase and everything else, I think the dielectric and the is another front, right, that there can be some innovations in, right? We're talking about blending, we're talking about plasticizer, we're talking about all of these, there's everybody pushing this and testing this, and as we do that, it's going to bring more and more people. 9 months ago, when I took a look at the market, there was like 8 companies that I was like, oh, you can go buy dielectric from them, right? Every week there was a new company coming out. Oh, we got a new dielectric, whatever. It was like, okay, let's take it slow. We got to prove it and and run and test and verify. But I think it is definitely the future. If it's the future, the demand will grow. Supply will grow to meet that demand. My concern is, I think what Philip said, right? The more competition you have, the easier it is to grow that. And I think the more people that can adopt it and have access to it, it is important, right? The faster the adoption rate will happen.
I'll give you just a slightly different perspective and a shameless plug for DaVinci. So our Dragonfly miner is manufactured completely in the United States. So we're vertically integrated to have control over it. And we've got capacity for 1,000 units a year. And so we have the ability to scale up very quickly because we own the whole supply chain. It's a completely vertically integrated aside from the ASICs currently. But that allows us to scale up very quickly. And being made in the U.S., as many of you probably know, there's a new bill that's just passed for bringing chip technology, high-tech technology, back to the United States. So there will be significant incentives for companies like ours to start to do things more here in the United States, more control, capacity, and supply chain.
All right, guys, we have one more question, but we're going to need quick answers.
It's kind of in line with what was already being talked about, but basically the rate of adoption for immersion and liquid cooling, what you guys predict over the next 3, 5, 10 years. We're going to see as a trend in terms of proportions, if you look at like a pie chart, air-cooled, liquid-cooled, immersion-cooled, and what you think the driving forces of having, say, a majority of systems being immersion-cooled, say, in the next decade, what driving forces you think are going to happen to potentially make that a possibility?
Well, if mining is anything like the other industries that we're seeing, whether it's high-powered compute, lithium-ion batteries, everything is going to be immersion-cooled. Primarily because of something that was said earlier, which is as the as these chip nanometer sizes get smaller, we run into this problem where as a device gets very small, it's very hard to get rid of all that heat. So we have to come up with something more effective. Keep in mind that when computers were first invented, they were all liquid-cooled. Right, UNIVAC and all these were all tubes, and they were all cooled with liquid. Then we had the air revolution, right? We brought in microchips, and we could figure out how to get them. But now they're so small and so dense, and there's so much energy contained in these, and we continue to push them with overclocking, that there really aren't any more effective methods. I mean, I think the next thing we'll be doing is probably immersing them in liquid nitrogen and things like that. But at that point, we have to have devices that are designed for that environment. One of the advantages of immersion, we're taking devices that were never designed to be immersed and able to make them more effective and cool them better. So I think what we're going to see, at least based on what we see in the industries outside of mining, is a faster and faster adoption curve around immersion cooling until the next wave comes.
Okay, I think that's all the time we have for questions for now. Thanks everyone for listening.